Okay, welcome back everyone. So in this video, we will talk about finite difference methods using Taylor series uh, approximation. So let us say I have a grid that is defined as x0, x1, xi minus 1, xi, xi plus 1, and so on and so forth, and it will go till xn. Now I want to find out first order derivative, that is dy over dx at xi and d2y over dx square at xi. So I want to find out these derivatives, or if the methodology is properly understood, then we can find out the third order derivative as well at point xi, and so on and so forth. We can find out any order derivative. So let us start with the first order derivative, that is first order derivative. So suppose we are solving for temperature. We want to find out the derivative of temperature, that will be dt over dx. So the part 1a is first order derivative, and for that I have first forward difference formula. What I mean by forward difference formula, suppose here we have xi, here I have xi minus 1. So in forward difference, derivative will use the previous values. I mean, for xi we will use the values xi minus 1 and xi minus 2, and so on and so forth. So first order derivative, let us write down that I have this xi plus 1, or in forward difference formula, the will use the next values. That means it will use the x values xi plus 1, xi plus 2. So let us write down the Taylor series, that t at I plus 1 is equal to t at I plus xi plus 1 minus xi dt over dx at xi plus xi plus 1 minus xi to the power 2 upon factorial 2 d2t over dx square at xi. So let us say this is my truncation error. That means what I have is dt over dx at point xi is equal to nothing but t of I plus 1 minus t of I divided by x of I plus 1 minus x of I plus x of I plus 1 minus x of I divided by factorial 2 del 2t over del x square at point xi. This is minus, and this is nothing but my error. So the formula will become dt over dx at xi is nothing but ti plus 1 minus ti divided by xi plus 1 minus xi plus order of delta x del 2t over del x square, and this is nothing but error of approximation. This is my forward first forward difference form of first order derivative. Now let us write down the backward difference form. Backward difference form is nothing but, suppose I want to find out the values. So in case of backward difference, it will use these values, not the next values. So let us write down that t of I minus 1 is nothing but t of I minus xi minus xi minus 1 del t over del x at xi plus xi minus 1 whole square divided by factorial 2 del 2t over del x square at xi, and so on and so forth. So that means my first order derivative with backward difference formula will become t of I minus t of I minus 1 divided by x of I minus 1 plus order of delta x del 2t over del x square at xi. So this is my backward difference formula. Now let us go to the last part of this first order derivative, that is central difference form. So what does central difference form says? That I have this value at xi, so the derivative at this point will include values from the right as well as values from the left. So let us write down the Taylor series for ti plus 1 is nothing but ti plus xi plus 1 minus xi del t over del x at xi plus xi plus 1 minus xi square divided by factorial 2 del 2t over del x square at point xi, and ti minus 1 is nothing but ti minus xi minus 1 is equal to del t over del x at point xi plus xi plus 1 xi minus 1 upon factorial 2 to the power 2 del 2t over del x square at point xi plus. So for the sake of simplicity, let us say xi minus 1 is equal to xi plus 1 minus xi is equal to delta x. So this becomes that I have ti plus 1 is equal to ti plus delta x del t over del x at point xi plus delta x square upon factorial 2 del 2t over del x square at xi plus delta x cube upon factorial 3 del 3t over del x cube at point xi is going, and ti minus 1 is equal to ti minus delta x del t over del x at point xi plus delta x square upon factorial 2 del t2 over del x square at point xi minus delta x cube upon factorial 3 del 3t over del x cube at xi plus. Now let us subtract these two. So what will come out of this is that del t over del x at point xi will be ti plus 1 minus ti minus 1 divided by 2 delta x plus order of delta x square del 3t over del x cube at xi. So this is the form, and this is error, which is of second order. So this is second order accuracy. So for del t over del x at xi, we have forward, that is ti plus 1 minus ti upon delta x plus order of delta x. Backward, ti minus ti minus 1 upon delta x plus order of delta x. Central, ti plus 1 minus ti minus 1 divided by 2 delta x plus order of delta x square. This is my second order accuracy, and both of these formulas are having first order accuracy. So we have talked about the first order derivative. In the next video we will talk about the second order derivative.